Hi all, this is Bharatraj. I'm studying BTech first year CSC A section. My roll number is 21951 capital A 0522. Today my concept video is superposition theorem for DC excursion circuits. Statement of superposition theorem. The superposition theorem states that in any linear network containing two or more sources, the response in any element is equal to the algebraic sum of response current caused by individual sources acting alone while the other sources are inoperative. In any linear network containing two or more independent source, voltage or current source or combination of voltage and current source, the resultant current voltage in any branch is the algebraic sum of current by voltage caused by each independent source acting alone, with all other independent sources being replaced meanwhile by their respective internal resistance. Superposition theorem can be explained through a simple resistive network as shown in figure, and it has two independent particular voltage source and one particular current source. In this circuit, we can see four resistors are connected. The four resistors R1, R2, R3, and R4. One may consider the resistance R1 and R3. R1 and R3 are the internal resistors of the voltage source, where the resistance R4 and R4 is considered as internal resistance of the current source. The problem is to determine the response current in the resistor 2 R2. The current can be obtained from according to the application of according to the applications of the superposition theorem. It may be it may be noted that each independent source is considered at a time while all other sources are turned off or killed. To kill a voltage source means the voltage source is replaced by its internal resistance, where to kill a current source means to replace the current source by its internal resistance. To consider the effects of each source independently require that source be removed and placed without affecting the final result. To remove a voltage source when applying this theorem, the difference in potential between the terminals of voltage source must be set to zero. That is short circuit. Removing a current source requires that is terminals be open. That is open circuit. Any internal resistance or conductance associated with the displaced sources is not eliminated but must still be considered. Figure reviews the various substitutions required when removing an ideal source and figure revise the substitute with particular source that have an internal resistance. The total current through any portion of the network is equal to the algebraic sum of the current produced independently by each source. That is, for a two-source network, if the current produced by one source is in the one direction, while that produced by the other is in the opposite direction through the same resistor, the resulting current is difference of the two and as the direction of the larger. If the individual currents are in the same direction, the resulting current is the sum of the two in direction of either current. This rule hold true for the voltage across a portion of a network as determined by polarities, and it can be extended to network with any number of sources. The superposition principle is not applicable to power effects since the power loss in a resistor varies as square nonlinear of the current voltage. We are taking an example. Find the current flowing through 20 ohms resistor of the following circuit using superposition theorem. Here we have a circuit we have to find current at 20 ohm resistor. First of all, we have to few steps to solve superposition theorem. That there are steps to be followed to apply the superposition theorem. Step 1. Select any one energy source. Step 2. Replace all the other energy source by their internal series resistance for voltage source. Their internal state resistance for current source. Now step 3. With only one energy source, calculate the voltage drop or branch current, paying attention to the voltage, polarities and current direction. Step 4. Repeat steps 1, 2 and 3 for each source individually. Step 5. Add algebraic the voltage drop or branch current obtained due to the individual source to obtain the combined effect of all the sources. This is the steps to follow to apply the superposition theorem. Now we will see one example. Yeah, we have a circuit. We have four resistors. First of all, step 1. Let us find the current flowing through 20 ohms resistor by considering only 20 volts voltage source. In this case, we can eliminate the 4 amp current source by making open circuit for it. The modified circuit diagram is shown in the following figure. We remove that 4 amps current and the modified circuit is this. There is only one principal node except ground in the above circuit. So we can use node analysis method. The node voltage V1 is labeled in the following figure. Here V1 is the voltage from node 1 with respect to the ground. Here V1 is the node with respect to the ground. No, the nodal equation at node 1, that is V1 minus, that is V1 minus 20 by 5, that is plus V1 by 100 plus V1 by 10 plus 20 equal to 0. Then 6 V1 minus 120 plus 3 V1 plus V1 by 30 equal to 0. 10 V1 equal to 120. Therefore, voltage V1 equal to 12 volts. The current flowing through 20 ohms resistor can be found by doing the following simplification. That is, I1 equal to V1 by 10 plus 20. Substituting the values of V1 in the above equation, and we will get I1 equal to V1 is 12 by 10 plus 20. So we will get 12 by 30. That is 0.4 amperes. Therefore, the current flowing through 20 ohms resistor is 0.4 ampere. When only 20 volts voltage source is considered. Now step 2. Let us find the current flowing through 20 ohms resistor by considering only 4 amp current source. In this case, we can eliminate the 20 volts voltage source by making short circuit of it. The modified circuit is shown in following figure. In this time, we remain voltage, and the final diagram is this. In the above circuit, there are 3 resistors to the left of the terminals A and B. We can replace this resistor with a single equivalent resistor. Here 5 amps resistor and 10 amp resistor are connected in parallel, and 10 with the combination is series with 10 amperes. Sorry, 10 volts. Sorry, 10 ohms. The equivalent resistor to the left of terminal A and B will be, therefore RAB equal to 5 into 10 by 5 plus 10 plus 10. That is, this is parallel and plus series equal to 10 by 3 plus 3. That is 40 by 3 ohms. The simplified circuit diagram is shown in the following. That is, we get ohms 40 by 30, 40 by 3 ohms and 20 resistance and 4 ampere. We can find the current through the following 20 ohms resistor by using current division principle. That is, I equal to IS into R1 by R1 plus R2. Substituting IS equal to 4 ohms and R1 equal to 40 by 3 ohms and R2 equal to 20 ohms. In the above equation, I2 equal to, with taken is equal to 4 amps and R1 equal to 40 by 3 ohms and R2 equal to 20 ohms. And if simplify, we will get 1.6 amps. Therefore, the current flowing through 20 ohms resistor is 1.6 amps. When only 4 amps current source is considered. Now, step 3. We will get the current flowing through 20 ohms resistor of the given circuit by doing the addition of two currents that we got in step 1 and step 2. Mathematically, it can be written as I equal to I1 plus I2. And we will get, first we will get 0.4 and then we will get 1.5, 1.6, that is 2 amperes. Therefore, the current flowing through 20 amps resistor of given circuit is 2 amperes. This is the steps while following. We need to follow these 3 steps to calculate superposition theorem. Therefore, the current flowing through 20 ohms resistor of a given circuit is 2 ohms, 2 ampere. Now, note, we can't apply superposition theorem directly in order to find amount of power delivered to any resistor that is present in linear circuit. Just by doing the addition of powers delivered to the resistor due to each independent source. Rather, we can calculate either total current flowing through or voltage across that resistor by using superposition theorem, and from that we can calculate the amount of power delivered to the resistor using, that is I square R or V square by R. So the current flows at 20 ohms resistor is 2 ampere. And now the limitations of superposition theorem. Superposition theorem does not work for power calculation. The superposition theorem cannot work for power calculations because power calculations involve either the product of voltage and product of current. The square of current or the square of the voltage, they are not linear operations. Superposition theorem cannot be applied for non-linear circuit. This method has weakness in order to calculate load current or load voltage for the several choices of load resistance R of the resistive network. One need to solve for the every source voltage and current several times. With a simple circuit, this is a fairly easy, but in large circuit, this method become an painful experience. Painful experience. So these are the limitations of superposition theorem. And next, I am repeating once again the steps to follow to apply the superposition theorem. The step 1 is select any one energy source. First, select any energy source and replace all other energy source by their internal series resistance for voltage source and their internal shed resistance for current source. Step 3. With only one energy source, calculate the voltage drop or branch current, paying attention to the voltage polarities and current directions. Then step 4. Repeat step 1, step 2 and step 3 for each source individually. You need to repeat all these steps for all individual resistance. Add algebraic add algebraical the voltage drop or branch current obtained due to the individual source to obtain the combined effect of all sources. We have solved one example also, and the power equal to I square R or V square by R. And we discussed the limitations of superposition also. The superposition theorem advantages are it helps in determining the it, it helps in determining the individual response of source and it determines the behavior of the current. These are the advantages of superposition theorem. In superposition theorem, we can also apply mesh analysis and node analysis also. The another statement of superposition theorem is in a network containing linear impedance, impedance does not change with the flow of current and the energy source generated the current energy source generated the current the flow of current and the energy source generated the current flowing any point is the vector sum of the current which would exist if each source of PMF was considered separately, all the other sources being replaced at the time by their internal impedance. So these are the limitations and statement and steps to follow superposition theorem. And this is my concept video of BAA superposition theorem. And thank you. Ah.